Hi, I am Daniel Donnelly, and this is Iceland, a Geologic History. The present location of Iceland, plate, ridge, coastline, oceans, or zones. Iceland is a very unique situation on our planet. It contains almost all of the geologic activities that can occur with plate tectonics. First, Iceland is in the North Atlantic and was created from a mantle plume. This hotspot is over 100 million years old. Iceland, however, is also at a spot where there's a mid-ocean ridge. That ridge is where the North American and Eurasian plates meet. That is called the Mid-Atlantic Ridge. This causes Iceland to not just be an island created from a hotspot, but on a divergent plate boundary. Iceland's general mineral composition, whether it's basaltic, granitic, or a mixture, and why. Iceland has both a hotspot and a plate divergence, so you can get both types of rocks, granitic and basaltic. It's majority basaltic. From the hotspot is what majority created it. This meaning the majority of Iceland's formation is from the asthenosphere, where majority of the mantle material is basaltic and little granitic. This leads to why Iceland has very cool rock structures that you normally wouldn't find in other places. So from volcanoes, Iceland has been created and spreading because of the ridge, resulting why 90% of it is basaltic rock and the other 10% of it being from granitic formations. Iceland's creation history and the time periods during which the major geologic history occurred. 100 million years ago, the plates split, creating the Mid-Atlantic Ridge. Simultaneously, a volcanic plume was created right under where Iceland is now. Over millions of years, volcanoes that formed started spewing hot basaltic magma that has hardened, creating a so-called land bridge between these two plates. 3 million years ago, an ice age then created glaciers on Iceland, which after this period melted, creating massive erosion, leading to many of the valleys and fjords that are still there today. Iceland still maintains these glaciers and ice caps, but they do still melt every summer when there is climate change. The main geologic mechanisms that lead to the creation of Iceland. The majority of Iceland was created from volcanoes, from that mantle plume. Iceland has the Mid-Atlantic Ridge and a hotspot making up for the reason for those volcanoes. Iceland also has fracture zones from the Mid-Atlantic ridge that leave behind when it spreads. Because of all of this activity, Iceland suffers from active volcanoes and earthquakes very frequently. The spreading of these mid-ocean ridges and volcanoes from the hotspot creates a one-of-a-kind structure. Iceland's current situation, what is it doing, and what problems does it have? Iceland today is still very active and moving. With earthquakes almost every day and active volcanoes that could blow any time, Iceland is very susceptible to change. One major issue for Iceland is easy to understand, and that is splitting apart. Every year, a few inches split, creating new land, and Iceland has to have problems with the fault lines and the ridge itself. The other issue, mentioned before, is the amount of frozen water and wind that Iceland has from season changing, and because of this, Iceland has occasional flooding. Flooding, paired with the wind that wears down the glaciers and earthquakes that shake, eventually something is bound to break loose or collapse. What will happen to Iceland in the future? If melting glaciers continue, then Iceland will eventually lose its fishing, which is a major source of its national income. Another issue is Iceland is constantly spreading, but maybe not anytime soon, but eventually it will split into multiple islands. These two issues, on top of the global temperatures rising, can lead to Iceland potentially becoming uninhabitable. This is a divergent plate boundary. It's one of the mechanisms changing Iceland's landscape. It's a mid-ocean ridge sits on it. With it being a divergent plate boundary between the North American and Eurasian plates, it is slowly splitting apart. It also has a mantle plume and rift zones. You can see on this diagram to the right the areas where all the volcanoes and major activity take part. This also shows where the heart of the mantle plume is located. This, plus the fact that we have many active volcanoes, is why it has lots of volcanic activity. You can see these big rift zones here. Iceland also has a fault system from the mid-ocean ridge. Iceland, because it is in the middle of a ridge, has faults in the middle of the island. These faults, when mid-ocean separation occurs, rub against each other, creating lots of earthquakes. This is very common here and happens almost every day. On top of the separation itself, Iceland is splitting at 3 places at the same time. Thank you, and it was fun.